this was originally hatched out of a personal hobby of growing carnivorous plants, and in every cultivation book that I've looked at, they mentioned that pretty much all carnivorous plants have a sensitivity to mineral water or water with a mineral content greater than anywhere from 80 to 100 ppm, but none of them can say exactly what is in the water that's causing poor growth in plants. But all of them say don't use it, don't go anywhere near it, or your plants will die. And just from personal experience, accidentally using some higher ppm water, they do in fact die. They decline really, really quickly, and then that's that. But since none of them could say why, I took it upon myself to do an undergraduate research project and just kind of do a preliminary study and see if I can pinpoint that down. Rajnovsky-Sudkova in 1953 published a paper in Czech about the calcium tolerance of Drosera rotundifolia, and he was looking at a wider study on the range of plants in general, the whole calcifuge, calcicol problem, but he wasn't really able to positively identify anything other than Drosera rotundifolia was really, really sensitive to calcium at lower pHs, but as you increase the pH, it got more and more sensitive. And Adamek in 1992 just took unfertilized natural soil and grew some Drosera in it as part of a larger nutrient study. And when he alkalized the soil without addition of anything else, just raising the pH, the plant suffered and died. So we have some explanations, but not a lot. It seems like it might be calcium. And although lots of studies looking at plant carnivory add nutrients just as part of the study, you know, all right, if we add it to the soil, do we see a growth response? Do we add prey? Is there a growth response? That sort of thing. But there's such a wide variety of methods used that it's really, really hard to draw any positive conclusions from that. So with that in mind, I went and grew some Drosera capensis from seed. And my treatment groups consisted of 5 medium and 5 small plantlets that were matured for 265 days. And there's just a little size comparison there with a Canadian penny to show just how small these plants were. While there was some growth, they remained small throughout the entire experiment. And once I went and watered them each week, I took the live leaf number, just how many there were alive, how long they were, and the exact amount of, well, not exact, but the amount of dew just on the leaves. In the cultivation guides, it's mentioned as a dew response. And because I'm looking at sort of a tap water response, I went and used 20, 80, or 320 milligram per kilogram solutions of either calcium chloride, magnesium chloride, or potassium bicarbonate, and just mixed those up into a water solution and used that to water them each week. And once all the data was collected, I analyzed it using the Minitab 15 software and just did some ANOVA comparisons to see if there were any differences. Well, there weren't any significant differences just because I think the plants were too small. We could see some nice preliminary results at using calcium at the low concentrations. The growth response was actually positive throughout most of the experiment, so the plants were larger in comparison to a control. But as we went to the medium, the 80, and the 320 milligram per kilogram solutions, the plants suffered, and we saw a very similar response to the poor growth in the unknown tap water things that we see in the books. So Adamek in his 2002 paper actually found deposition of calcium into senescing leaves of Drosera capensis under sort of high calcium soil conditions. Normally plants like to take up nutrients from dying leaves just so they can reuse them. But in the case of calcium and magnesium, these were the only 2 plant nutrients that were actually deposited within senescing leaves, like they were trying to get rid of it. So it may be a regulatory mechanism in place so to deal with this sort of calcium or magnesium stress. And it looks like, just given the concentrations that I looked at, it wasn't a high enough resolution to pinpoint it exactly, but it looks like it fairly matches the nutrients, or the tap water, sorry, problem in the cultivation book. So it might be a nice explanation there. Magnesium, we also saw a little bit of a poor growth response, but that was only at the high concentration at the end of the treatment. And again, we saw the deposition of magnesium into senescing leaves. And in the potassium bicarbonate treatment, even though the pH was a lot higher than the other experiments, around 5.5 for calcium and magnesium, around 7 to 8 for potassium bicarbonate, we would expect really, really poor growth given what Adamek found in his paper, but it was fairly close to the control for all of them, despite having a soil pH of about 8. And an interesting thing to note in this one, this level of treatment though, is at the high concentration, the plants completely ceased dew production about mid-week, just sort of right in the middle of the treatment week, or the treatment set. And the explanation for that is likely that they reduce their dew production in response to certain high levels of nutrients in soils. So Thorin et al. In their 2003 paper found reduced dew production or reduced investment in carnivory with NPK fertilizer. So I think that's what's responsible here. It's not an actual stress response, it's just doing that sort of thing. Some future directions that I'd like to take this sort of branch of research in is looking at different carnivorous plants. So I looked at one species and one genus. I'd like to go and extend this into other plants, the Venus flytrap, bladderworts, that sort of thing, and look a little bit more at controlled pH. In this experiment, I just kind of let it go, but I'd like to control the pH in some other experiments and see how much that affects the sensitivity and try and pinpoint the actual level of calcium that's hazardous to these plants there. I'd also like to go and look specifically at some sundews that undergo dormancy, either the winter-growing sundews of Australia, where they form a tuber under the ground in response to really, really hot, dry conditions, or the winter dormancy in sundews around Prince George, Canada, where they'll actually form a bud in response to the really, really cold winters. And I'd also like to go and take a little bit of a look at the ecology and possibly the population genetics of Drosera in northern BC, and just see how related are these species within a bog, where are they found in one area versus another, and that sort of thing. So I'd like to thank my supervisors, Arthur Ferdine and Hugues Massicot, and thank you for listening.